This is the first of 2 videos on GGPLOT, the very popular plotting package. What I love about GGPLOT is that it allows you to build quality plots very quickly. The first thing we need to do is to get set up. I'm going to create a new project for the week. I'll call this GGPLOT. And I need a new script, and I'll save this as graphing with GGPLOT. If you haven't installed it before, we'll need to use the install.packages and GGPLOT2. And then we'll need to call that package using library. And oh, there's no package called GGPLOT because I forgot the 2. There we go. This week we'll be using data on an acacia tree, or as a type of shrub in the Kenya exclusion experiment, where they've excluded large herbivores and they've measured the difference of acacia size inside and outside the exclosures. We'll need to download the data, and I'm going to copy and paste from our Canvas out. Download data. And I'm going to double check everything looks okay. So we're using this acacia survey. The separator is tab because it's a .txt. And the NAs, wherever there's an NA, I want R to classify those NA values as dead, because I know that the trees with NA values are because they were no longer living. Let's look at the data. The first thing you want to do when you import data is to look at it. So remember, I can click on the object name in the environment, which automatically sends this command to the console, view acacia. I could also write that in our console directly. So it looks like we have different surveys and different years, sites, treatment. So it looks like there's different treatments, and you could read more about it on our Canvas, as well as different heights and circumferences. Let's start by building our first GGPLOT by calling GGPLOT, and you can see the different arguments. So it takes data and something called aesthetics. The AES are the primary arguments that we'll be working with. In this example, we want data to be our acacia object, and mapping will be the AES, aesthetics, and it expects an X and Y argument. So our X-axis, we want circumference, and our Y-axis, we want height. So we want to plot the height of each tree versus the circumference of that tree. Maybe we're interested in allometric scaling. If we run this command, we can see that it creates the axes, but it doesn't create the figure. It's basically a blank canvas, and it maps some default values for data. And so we need to add the piece of the plot. We need to add the data points themselves. To do that, we're going to add elements. So we need that addition symbol, and There's lots of geometries in GeoPlot. If you type out geometry and scroll, you can include box plots, bar charts, uh, density, kernel densities, all kinds, and even rasters. We'll see that later. The one that's most common is geopoint. So this is a scatter plot. And we'll need to run all the entire command again in order to add the data points onto the graph. We can customize things about the layer that we pass arguments to in each geometry. For example, we can change the size of each point, the color, and recognizes kind of standard colors in quotes. You can also provide the hex code or RGB code if you're into color palettes. And we can change the transparency as well. So let's run this command again with the modifications, and we can see we have a bigger point size. It's blue, and the transparency is 50%. So we can see when data points are stacked on top of each other. Let's make our graph easier to read by adding another layer. Let's add labels onto our axes. Let's designate the x-axis as circumference in centimeters and the y-axis as height in meters. And let's give this a title equals Acacia Survey at Uhuru, which is the name of the experiment in Kenya. And I get a error here, unexpected token. That's because I closed my parentheses before I included the title. And maybe I'll clean this up a little bit, making it easier to read. All right, we can run that command again and see how that modifies the axis label and gives a title to the plot. So in this plot, we're seeing that height scales with circumference across all the different sites and plots and treatments, but maybe there's a difference between how height scales with circumference depending on the treatment. So let's group on this graph and look at the influence of the experimental treatment. Let's group. In fact, I am going to copy these lines, reduce the amount of typing, as I still want to use the same data set and to group by a certain factor. You want to use color or fill inside of the aesthetics parentheses, because I will recognize that as using the different factors in treatment. Let's see. So use the different factors as different colors. So let's go ahead and run this. And nothing seemed to happen because it's being overridden by this color here. So each layer overrides the previous one. So if I have a certain color here in this line, it will be overridden by a color specification in a lower layer. Point to make. Okay, so now we have the different treatments in different colors. And you can modify these colors as well. But maybe it's not so easy to see the different treatments here. Let's pull this out and make four different graphs using the same axes for each treatment. And we would do that using the faceting. So we would use facet wrap and on treatment. It takes this syntax where whatever grouping you want, use the tilde symbol and on the grouping. So let's go ahead and run this, and we should have 4 different plots now. And what I really like is it automatically shares the axes labels. So if we wanted to clean that up a little bit, oopsie, I need this, and I don't like how it's spaced because of the prior format. So I want to clean it up and run this. And now we can see those axes labels are cleaned up. And yeah, this is much easier to visualize. And we can see there's only a few, there's probably only one, unless they're exactly on top of each other. It looks like there's only one individual tree in this open treatment. So that's where there's no herbivore exclosures. It's probably because they've all been eaten. If you're familiar with allometric scaling, you often take the log of each axis. Let's look at an example where we're rescaling the axes. And I want a similar plot. I want to go back to the single plot. And instead, I want to scale the X and Y axes using the log 10. And I'll do the same for the scale X log 10. And I'll do it one more time so you can see the different options too. So scale X for date time, square root, time, so you can see the different options. And I'll run this command. So now it doesn't change the data, just the presentation of it. So notice how our axes are rescaled. So in the labels should be log 10 circumference. And there's a way to make subscripts and superscripts in your labels by using a combination of expression and paste, and you can look those up if you're interested. ggplot is building the graph by combining the information about what data we're interested in, the mapping of different parts of that data, so the aesthetics, the X and Y, the color, the groupings, and a geometry or geometric object to represent that data. In this case, it was a point, but let's look at another geometry like a line. There's many kinds of geometric objects. ggplot, this line here, sets the defaults for all additional layers, and we combine layers using the addition symbol, and again the order of those layers matters. Let's add a linear model to our basic plot. So I'm going to take this basic plot and let's add a linear model using this geometry called GeoSmooth. There's different methods. We want a linear model, but you can also use different methods as well. And if you're interested in those different methods, we can always question mark GeoSmooth and scroll down to the arguments to find method. So there's linear model, generalized linear model, generalized additive model, and so forth. And both the GeoPoint layer and the GeoSmooth layer are using defaults from the ggplot, right? Because let me try to bring up that yellow box again. Notice that the arguments are data, mapping, but typically you'll pull these in from ggplot. Otherwise, if you're going to work with different data in the same plot, then you would need to designate your data inside each of geometry. AES, I'm missing a parentheses. And same here, same for here. Right. Now go ahead and run this. And this is a information that GeoSmooth is using the formula y onto x, right? So this should be what you expect given the method that you specified. And it's a warning that there are 4 rows that were removed that had NAs and weren't plotted. And so now we see that linear regression line added, as well as the confidence intervals. So let me go back to the default. Okay, I'm going to go back to these default so that it's a little easier to read. And there, I'm missing a parentheses. All right, now I'm ready to do this by treatment. I've got my acacia, I've got my mapping, my aesthetics, and because I want this to group by treatment, I need to make sure that I specify the grouping inside of the aesthetics. And I'm going to delete the names of the arguments because R recognizes the first argument is the data, the second argument is this aesthetics. And I'm going to clean this up a little bit, making it easier to read. And I'm going to run this, and now we should have, right, we didn't add the facet wrap, so we have all of the linear regressions on the same graph. By using these geometries, what ggplot is doing is a statistical transformation. In the smooth, we've seen a statistical transformation that gives a model line. And in GeoPoint, we're seeing the raw form of the data with no transformation. Let's look at other statistical transformations, like with other geometries. Let's use ggplot on our acacia, and in this case we're only interested in the number of acacia in each treatment using a bar graph. We can see that, between the different treatments, maybe this treatment has slightly more individuals than another treatment, and we saw that there were very few individuals in the open treatment. What GeoMBar is doing is using a transformation called stat count to count the number of individuals within each group provided by our aesthetics argument. Let's look at the distribution of circumferences in the dataset using a histogram. Let's ggplot acacia. Instead of treatment, we're interested in circumferences. And let's use the histogram geometry, and we can modify the fill by indicating the color. And again, we have some information here. There are 4 rows that had NA values. And here the bins, there's 30 bins. So you can modify that using bin width equals maybe 2. Let's see how that changes. Makes it a little visually more pleasing. And you can see the different options for the histograms. You can specify the number of bins or the bin width. And if you scroll down to the bottom, you can see different examples. Our histogram is using a transformation called stat bins to split the circumference into different bins and counts rows in each bin. So we can set bin width or the number of bins. Let's change this to 15 and see how the bin width is. Let's change this to bins, because that's the total number of bins is 15. And of course, these can be combined with other layers, like if we wanted to change the labels or give it an access title. Let's look at an example of how we would change values across layers. We can also plot data from different columns or even different data frames on the same graph. And to do this, we need to better understand how layers and the defaults are work. So far, we've put all the information inside of our ggplot aesthetics, but if we want to plot multiple things, then we need to pull those out into our unique geometries. Let's see an example of that. Let's start by calling ggplot and adding a layer called geomPoint using our acacia data. And our aesthetics, we want circumference on the X and height on the Y. And we want to color by treatment. And notice that these are my column names inside of my data object. And I'm getting an error. Mapping must be created by AES. GeoPoint. AES, X equals circ, Y equals height, color equals treatment. Mapping. Maybe it expects this mapping. Let me experiment. GeoPoint. I guess the newer version of ggplot expects this mapping argument. That's good to know. And we can see when we provide the data inside the geometry, it's no longer shared with additional layers. So if I try to run this, the geom smooth isn't added because there's no data. Instead, we would have to provide the data as well as the mapping. And I'm going to copy and paste. And now the smoothed geometry is included. Let's see what happens if we remove this color argument. To understand the different layer inputs. So we have the geom point where we've specified the grouping by color, by treatment. But in geom smooth, if we had forgotten this argument, the smoothing would have been made across all values, all points. This same sort of change can be used to plot different columns on the same plot by changing the values of x and y. So maybe you wanted to plot height and circumference from the Acacia data set, as well as height and circumference from another data set. So you would pull in different data objects, and you would need to make sure that the axes and the values are similar so that they can plot on the same. But of course, you can modify xlim, the limits of each axis. So maybe I had another data set that was the circumferences were greater, maybe 50 and 60, then I would need to change my xlim to go from 0 to 60. And that would expand the data, the graph. All right, there's a few other arguments. There's lots of different themes in ggplot, and these control in the color of this background here, whether there's lines or not. And I'm a classicist, so I'll go with theme classic, but you can definitely explore the different options here. I think that's a little cleaner, and I'll get rid of this since I don't really need it. All right, so I've got my plot, and now I'm ready to export or save my plot as a new file. To do this, I'll use ggsave, and I'll give it a name. Maybe I'll store it in the figures folder, Acacia by treatment, and I'll save it as a .jpeg. You can save it as .png, .tiff, and there's lots of optional arguments here. I always specify the height as well as the width, and you need to give the units if you specify height and width, otherwise it'll be interpreted as I think inches is the default. Let's see. Question mark GG save. Units. Let's look at the units here. If not supplies, plot size and units. If not supplies, use the size of current graphics device. That's not this here. So that would be the graphics device here. So I use inches because it's easier for me to think in inches than it is centimeters. But if you're from a country where you grew up thinking in centimeters instead, then you might give the units in centimeters. And I'll run this and I'll get an error message Because unable to open file, that's because I don't actually have a folder called figures. And now if I rerun this, if I look in my figures, there's the plot. So continue to the next video where we'll talk about publication quality figures in a little more detail.